misi yang satu, misi kita baru.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, salam sejahtera kepada semua guru, ibu bapa dan juga belajar-belajar sekalian. Selamat datang ke Pusat Tuisyen Akademik YouTuber dengan usaha sama e-didik Malaysia dan juga Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Cikgu memperkenalkan diri dulu. Nama saya Cikgu Kok dari SMK Tinggi St. David, Melaka, selaku sebagai moderator pada petang ini. Okay, hari ini kita bersiaran langsung daripada channel Mr. P. Siapa yang masih belum subscribe, silalah tekan butang subscribe kepada tanda sokongan kepada Mr. P. Okay, saya memperkenalkan Mr. P dulu. Okay, Mr. P ialah dari Kolej tingkatan 6, Tun Fatimah Melaka, selaku sebagai presenter pada petang ini. Okay, turut berada di konting kami ada Cikgu Hasnita dari SMK Pakan Jaya Butterworth, Pulau Pinang, selaku sebagai control host. Okey, kita akan mempelajarkan fizik tingkatan 5 pada petang ni dengan tajuk 5.3 Transistor DLP. Ada nota ada bahasa Melayu dan juga bahasa English. So cikgu pun guna dua bahasa untuk buat penerangan. Okey, kelas ini akan berlangsung lebih kurang 1 jam. Sebelum kita nak teruskan kelas ni, cikgu ingatkan kepada semua pelajar dan juga penonton yang ingin menghantar komen, sila guna bahasa yang sopan dan juga gambar profil yang bersesuaian untuk tontonan umum. Okay, link e-sijil juga akan diberi di hujung siaran. Link e-sijil dapat diisi dengan guna email e-didik, MO email, email my guru dan juga email Jawi. Cikgu akan beri kod di sepanjang kelas ni supaya belajar boleh tebuskan mata kredit AYU, dan juga link rekod kredit belajar juga akan diberi tapi ialah di hujung siaran nanti. Okay, sila fokus kepada isi belajaran yang disampaikan oleh Mr. P nanti. Semoga kelas kita pada petang ni dapat dimanfaatkan sepenuhnya oleh para pelajar. Okay, baiklah. Cikgu sebelum nak mula, cikgu nak bagi kod dulu. Okey, kod yang pertama ialah A3. A3. Okey. So dengan ni saya menjemputkan presenter pada hari ini iaitu Mr. P. Okey, dipersilakan Mr. P.
Hello, selamat petang kepada semua. So saya presenter pada hari ini. Saya Mr. P dari Kolej tingkatan 6 Tun Fatimah Melaka. Dan di sini sesiapa yang berminat mendownloadkan saya punya nota dan latihan untuk kelas hari ini, bolehlah download di deskripsi link live ini, okay? Okay, so ini merupakan kelas tuition percuma daripada AYU. Okay, so kelas tingkatan 4 diadakan pada setiap hari Jumaat pukul 9.30 dan minggu ini kita ada Cikgu Nora Hafizan menyampaikan subtitle 4.4 Hukum Gas Siri ketiga. Dan kelas untuk tingkatan 5 diadakan pada hari Ahad seperti hari ini pukul 2 petang. Dan hari ini disampaikan oleh saya dan tajuk yang akan disampaikan adalah tajuk subtitle 5.3 Transistor. So ini merupakan panitia fizik AYU, okay, yang banyak memberikan sumbangan kepada pendidikan Malaysia untuk subjek fizik. So pada hari ini bersama konti di sini ada Cikgu Kok dan Cikgu Hasita. Terima kasih membantu saya pada petang ini. Okay, so as per mentioned just now, we are going to our last subtopic of the chapter 5, which is 5.3 Transistor. So to the learning center, we have two learning standard. The first one is explain the function and use of the transistor as a current amplifier. Another one is also the function of the transistor, which is act as an automatic switch. Okay, so today we have two learning standard. Okay, but the explanation is quite long lah. Okay, because each of the function they have their sub-function actually. Okay, so let us go through together. Okay, so firstly, what is the transistor? So the transistor is a semiconductor device used to amplify and switch electronic signal and electrical power. So this is the two main function for the transistor, which is amplify the current and act as the automatic switch. Transistor is made by joining the N-type semiconductor and P-type semiconductor in 3 layers. Okay, in last subtopic 5.2, which is presented by Cikgu Hasita, okay, we learned already for the diode we have combination of the N-type semiconductor and P-type semiconductor, which is in 2 layers. Okay, so for the transistor, they will be combined with the same N-type and P-type semiconductor, but is in 3 layers. Okay, so this one is the recall of the section 5.2, which is N-type semiconductor and P-type semiconductor. Okay, so for the N-type semiconductor is actually referring to major carrier, which are the free electron. Okay, so the pure semiconductor, which is silicon mainly, okay, germanium also one of the example of the pure semiconductor, is doping with the pentavalent, okay, pentavalent atom, which is from the group 15. So that is a extra free electron, okay, here. Okay, for semiconductor group 14, we had 4 electron valence. Okay, so we add on the topping material, which is from group 15, so they will be have 5 electron valence. So total up, they will be have 9 electron valence. Okay, so for one bonding, we need 2 electrons. So that for the 4 bonding of the covalent bond here will be have an excess of the 1 electron. So therefore, the major carrier for the N-type semiconductor will be 3 electron. So on the other hand, okay, so here you can look at the P-type semiconductor. P referring to positive now. So that means the product will be tends to be less electron here. Okay, so the major carrier here will be the hole. Okay, so hole will be the negative charge. Okay. Okay, so we will be topping with the trivalence atom. Okay, so here will be from the group 13. So here we give the example of aluminium. So that means that the valence electron for the aluminium or group 13 will be have 3 electron valence, while from the pure semiconductor, which is germanium or silicon, will be 4. So they will be lack of 1 electron. So here will be appear as a hole. So at the condition which is lack of the electron in the actual bonding needed, okay, so they will be become positive type of semiconductor. Okay, so as mentioned just now, the transistor will be have the joining together with P and N type semiconductor with 3 layers. So the 3 layer here means that they have the 3 terminals. So you can look at this figure. So this is the appearance, okay, appearance of the transistor. Okay, they have 3 leg. Okay, 3 leg, or here is 3 terminals now. Okay, so the first will be named as the emitter. Okay, here emitter, and then base, and together with collector. So we have 3 terminals here. Okay. Okay, so for the emitter, so here the emitter, the function of the emitter is to send charge carrier to the collector. Okay, so the collector will be here. So that means the carrier here referring to electron, and also the hole here. Okay, so here the explanation. So the charge carrier carried by the N-type semiconductor major will be electrons. For the P-type semiconductor will be hole. Okay, So the electron for the N semiconductor here will be sent to collector. Okay, so this is a function for emitter. Then for the second will be the base. So the base will be at the middle. Okay, at the middle. So the function is control the flow of the charge carrier from emitter to the collector. Okay, and the last will be the collector. So the collector will be here. So the function will be receive the charge carrier from the emitter. Okay. So for this example, okay, so the semiconductor used will be NPN. For N will be carried by electron. If I say later on you will see another type of the transistor will be PNP. So the carrier will be whole. Okay. Okay, so number 4, diagram shows a transistor consisting of 2 PN junction diode coupled end to end. Okay, so what means by this sentence? So you can look at the figure here. You can recall back the section 5.2 also. You can see for the diode, we have 2 layers, which is combination of P and N type of the semiconductor. Okay, so here we can have our first diode PN junction here, okay? And then the second will be here. So the BE referring to the base and emitter terminal. And then BC will be base and collector terminal. Okay? So the base is the middle part consisting of the thin layer. So the layer will be thin, okay, for the base. Okay, so for the right side of the transistor here, we're referring to the emitter diode. Okay, as per mentioned just now, the BEB referring to the base, and then E referring to the emitter. So these two combination or combine of these two semiconductor here, P and N, will be known as the emitter diode. Okay, and then the left side here, referring number 2 here, BC. So will be joining together for the N and P. So it is the terminal, collector, and the base. Okay, so this is the collector diode. So that means for the transistor is actually consists of 2 diodes lah. Okay. Okay, so figure shows 2 types of the transistor. The NPN transistor. So this and the PNP transistor with their respective symbol. So you can see both of the transistor. For the NPN, so the emitter will be negative type of the semiconductor. Okay, and then the base will be sandwiched by 2 N-type semiconductor. Okay, and then for the PNP, the base, which is the N-type semiconductor, will be sandwiched by 2 P-type semiconductor. Okay, then the second observation here, you can see there is the difference at the arrow, okay, between base and the emitter. Okay, so where the NPN will be pointed from B to E. Then for the PNP will be from the E to B. Okay, so note that the direction of the arrow on the transistor symbol is always from P to N. Okay, so you can see the arrow. Just now I mentioned that the arrow is from B to E for the NPN transistor, and then for the PNP will be from E to B. Okay, but you can see both will be from the positive type of the semiconductor to the N. Okay, both will be the same. Okay, so the arrow actually showing that there is a direction of the flow of current. Okay, when the transistor is turned on in the circuit. Okay, so what is the importance part for these 2 arrows? Okay, to let you more clear why the arrow is different. Okay, so you have to know the emitter. Just now I mentioned already, the function is to send charge carrier to the collector. So that means they will be send electron. Okay, send electron for the transistor NPN. And then for the bottom part, PNP will be send whole, okay, to the corrector. Okay, so the E, that means the emitter, is the N-type semiconductor. So electrons are the major carrier which flow from the E to B, from the E to B. Okay, so the current flow will be opposite the direction of the electron. So that means the current will be flow from the opposite direction. So it will be from B to E already. So that's why you can see that the statement number 6 mentioned that both of the arrow is actually from P to N. Okay, so for the bottom part, okay, so the E is a positive type semiconductor. So the whole or positive charge are major carrier and will be flow from the E to B. Okay, so the whole will be have the same direction of the current. Okay, so that's why you can see the arrow showing that the current is flow opposite, but actually both the carrier is sent from the emitter. Okay. Okay, so now we go to the transistor circuit. Okay, so here we have actually two types of the transistor circuit. Okay, so the first type will be the transistor circuit, which consists of the two battery or two power supply. Okay, so you can look at the NPN transistor circuit here. Okay, so they have two battery or two power supply, E1 and E2. So for the PNP, also the same, will be have two. Okay, so another type will be the transistor circuit with one battery or one power supply here. Okay, so here will be NPN, okay, circuit in our discussion. Okay, you can see there is only one power supply or battery here. Okay. Okay, so let us go to our first one. Okay, so the way of connection of the transistor by using two battery or two power supply here. Okay, so as we mentioned just now in our syllabus, okay, for the connection of transistor in two power supply, okay, they will be asking you regarding the transistor, NPN, also PNP. Okay, so the first, as we mentioned just now, both of them, they have the two power supply. The first will be E1. Okay, so the E1 is the supply energy to the base circuit. Okay, so base circuit will be as per label here. So it'll be here. Okay, so it's the connection between the base and the emitter. Okay, base and emitter. And then the E2 referring to the power supply. Okay, from the collector here. Okay, is E2. Okay, so the collector circuit will be here. Okay. Okay, so let us see detail for the base circuit. So it will be here and here. So the connection base emitter terminal is known as the input circuit or the base circuit. So the base circuit is also known as the input circuit. Okay, so that means that if let's say we don't have any current flow in the input circuit, so there will be no any current flow at the corrector circuit. Okay, later on we will discuss more detail. So for the corrector circuit is the connection corrector base terminal. So the corrector here C, okay, and base here. So these two terminal together we know as the output terminal. Okay, just now we mentioned that they have actually two diode, right? Okay, so the BE terminal referring to the emitter diode. Okay, and then the CB here referring to the corrector diode. Okay. Okay, so large magnitude of the corrector and emitter current get produced through a amplification of the small current IB. So that means to have the output, which is the IC, okay, which is the IC, and the IE with the bigger value of current, okay, so we need a small current of IB here. So the statement here is actually give you indirectly, okay, so the transistor is actually amplify the current now, okay, amplify the IB to IC and IE which have the higher value of the current now, okay. So actually it's mainly will be the IC lah, is the output current here. So the small current only get amplified when the transistor become active. So how we can activate the transistor? So that means that we need to have the smaller current flow. Okay, so this will be related to the junction voltage, okay, which you learn in the section 5.2. Okay, later on we also will be involved that in the discussion. Okay, and then for the PNP, so the current IE enter into the transistor through the emitter terminal. Okay, a small current will be IB, leaving the base is amplified in the corrector output. Okay, so you can observe the difference between MPN and the PNP. So it's the direction of the three current here, IB, IC, and IE. Okay, so for the MPN, so the current flow will be IB into the transistor. Okay, and IC also go into the transistor, and the IE here will be out of the transistor, which is same as the symbol represented as the direction flow current. So PNP will be opposite. Okay, so the base current will be from the transistor together with the corrector current here. And then the IE here will be flow to the transistor. Okay, which is showing by the direction at the symbol of transistor here. Okay, so here you can see that we have importance formula you need to understand here will be the IE will be equal to IB plus IC. So you can look at the figure for MPN and PNP also. So we can look at the MPN first. So you can see, so IE here, IB and IC will be here. So you can see both the IC and IE flow in to the transistor. So only the IE will be out. So that means the IE will be equal to IB plus IC. So there will be same situation at the PNP also. Okay, you can see that, okay, at the arrow here, current IB is out from the transistor. IC also the same. So there is IE only the only current here flow in the transistor. So the IE will be equal to IB plus IC lah. Okay, so this is the first relationship between IE, IB, and IC you need to memorize here lah. Okay. Okay, so here is the further discussion for the connection, okay, for the MPN transistor in two power supply. Okay. Okay, so the corrector C here, okay, is connect to the positive terminal of battery. You can see here, connect to the positive terminal. Okay, so the longer one showing this is the positive, the shorter one will be negative of battery. Okay, so it's here. Then the second, you can see that the emitter E will be here. Okay, it's connected to negative terminal. Okay, so here also the same. E from here to here is negative. From the another side, the base circuit also the negative. Okay. Okay, so why they will be connected like this? Okay, both of the C and E here. Okay, so as we mentioned just now that the emitter diode, which is the base and the emitter terminal. Okay, so you need to connect it in forward bias. Okay, so connected to forward bias, that means that you can see for the MPN transistor, the emitter here will be negative type semiconductor. So that means you have to connect to negative lah. Okay, negative here. Then for the P, that means it's positive. So the base is positive type of the semiconductor. So you have to connect to positive. B here, connect to positive. So there will be forward bias for emitter diode here. Okay, so the emitter base region is forward bias, so electric field and the carrier will be generated. So that means they will have the current flow through the small PN junction here. So the PN junction will be here. So that means with this connection, which is in the forward bias here, okay, so the carrier, so for this case is an N, so the carrier will be electron will be flow through. Okay. Okay, and then the next for the corrector diode here, so that means will be the base and the corrector terminal here. You have to connect with in this way or reverse bias here. So what means by reverse bias here? So that means the N type semiconductor for the collector will be connect to the positive terminal. So you can look at here. C have to connect to positive here because the C corrector here is the N-type semiconductor. So to connect in reverse bias way, so you have to connect to positive. Okay, so why? So you can see the base layer is very thin and the potential difference across the corrector is more positive. So you need to have more positive, which is in the reverse bias. Okay, so that most of the electrons are pulled across the base to the corrector. So here actually we have the wider junction here. Okay, so with the positive, more positive potential difference at the corrector here, which has the in-terminal positive. Okay, so more electron will be flow through lah. Okay, so in this way, okay, where the emitter diode connect in forward bias while the corrector diode here is in the reverse bias. This is actually is the transistor connecting in forward bias. Okay, so that means the transistor will only functioning with this connection. Okay, so this is for the NPN transistor. So for the PNP will have the same discussion, just opposite. Okay, opposite the terminal of the battery here. Okay, so you can see the first one, the C corrector here will be connect to the negative. And then for the E emitter will be connect to positive. Okay, here positive, here also positive. Okay. Okay, so just now I showed this one already. Okay, so the connection for the E will be positive lah. Okay, so again the discussion will be the same. So the emitter diode must be connect in the forward bias here. Okay, but here the emitter is P-type semiconductor. So P referring to positive, right? So that means it will be connect to positive lah. Okay, so E will be connect to positive. Okay, in E1 and E2 lah. And then for the base will be the negative type semiconductor. So you have to connect to the negative terminal. So B will be negative lah. So here will be forward bias lah. Okay, so that means will be a lot more hole to fall through. Okay, the PN junction here. Okay, the emitter base region is forward bias, so electric field and carrier will be generated. So the carrier here is referring to the hole lah. Okay, and for the BC, okay, BC terminal, which is the collector diode here, expansion will be need to connecting in reverse bias here. Okay, so that means the P-type semiconductor for the corrector will be connect to the negative terminal. Okay, so the reason here, the reverse bias corrector base part has generated hole. So due to the electric field, carrier or electron get pulled by the hole. So here got more hole here. So will be pull more electron to the corrector. So that means there will be more electron flow. Okay, flow through the base to corrector. So that means they will have the amplification of the current from the base lah. Okay. So that means in such a way, okay, so the transistor is connecting in forward bias lah. Okay, so will be only functioning if the connection is forward bias and the emitter diode, okay, base and the emitter terminal, and the base to the corrector terminal here, which is a corrector diode, has to be in reverse bias. Okay. Okay, so now we discuss the function of the transistor as an automatic switch for the connection which have the two power supply here. Okay. Okay, so here we have a two power supply. So here will be the first, here will be the second now. Okay, so the base circuit of the transistor is used as a switch to control the state of the transistor. So we're using the base circuit as the switch lah. Okay. Okay, so saya nampak Cikgu Faizal. Okay, terima kasih. Okay, so join live saya hari ini. So sebelum ini ada juga nampak pelajar lain kan, Anissa. Okay, Anissa, thank you for join my class. Cha Ying also. Okay. Okay, so when the base potential different. Okay, so sorry for the first dot will be the base circuit act as a switch. So how it can be act as a switch? So here will be in the off condition where the base potential different. Okay, so the base voltage here referring to the symbol VB, okay, is less than 0.7 is in the range of 0 to 0.7. So that means the transistor will be turned off lah. Okay, so the base potential difference you'll be referring to here lah. Okay. So that means that when the potential difference or the voltage of VB is less than 0.7, so the IB will be 0 because the electron not able to overcome the resistance in the junction voltage actually. Okay, so the IC will be 0. Okay, so the transistor will be off lah. Okay, so this is also the record section. Okay, just now we mentioned that the voltage, junction voltage, okay, so will be here. So here it will be the junction voltage. Okay, so in this connection, there is actually the PN junction diode in the forward bias. So in forward bias, that means that the depletion region will be narrow, okay, which will be 0.7 volt if using silicon type of the transistor. If I say using the germanium, they will be lower, okay, which is 0.3 volt. Okay, so the answer here between 0 to 0.7 here is referring to the silicon type of the transistor. Okay, so that means you need to have a minimum energy to overcome the voltage junction now, okay, which is equal to 0.7. Okay, if using the silicon type of transistor. Okay, so when our base voltage here is greater than 0.7 volt, the transistor is switched on. So that means the electron able to flow through the depletion region, and the hole also able to cross over the junction here lah. Okay. Okay, so large current flow through the corrector, which is in the symbol IC, and emitter. Okay, thus the transistor circuit can act as a switch by controlling the value of the VB. Okay, so that means if the VB less than 0.7, okay, so the circuit will be off. Then if the VB is greater than 0.7, so the circuit will be on. Okay. Okay, so that means that when the IB, there is the base current flow, the IC, which is the corrector current in the large magnitude, will be flow through the corrector circuit. Okay, if you substitute here 1 buck, okay, in the corrector circuit, they will be light out lah. Okay, so the transistor is on. Okay, so here the second function of transistor is to act as the current amplifier. Okay, so here is actually the continuous discussion from the just now the slide. Okay, we mentioned that the current will flow IB will be flow when the VB is greater than 0.7. Okay, so here, so a transistor function as a current amplifier by allowing a small current to control a large current. So that means we need to have the minimum VB here, 0.7 lah, okay, so that it can be function as current amplifier. Okay, so the working principle here will be the base current IB here. Okay, it's very small. Okay, you can look at the micro ammeter here. So the micro ammeter, that means that the current going to measure will be very small. Okay, so that's why we're using micro unit in micro. Okay, so for the collector, current will be milliampere. Okay, so will be greater lah. So here, from here we can know that the IB will be far smaller than IC. Okay, so the IC will be generated if the IB able to flow in the base circuit, which the value of VB must have the minimum 0.7 as per mentioned just now. Okay. Okay, so here, as per mentioned just now, the micro ammeter is to measure the IB base current. Okay, and then for the milliammeter will be measure the collector current here. So the characteristic of the transistor as a current amplifier can illustrated by graph IC against IB. Okay, so besides we can see the amplification of the base current, okay, to produce a large magnitude of the collector current. Okay, we can actually using the graph to, okay, show the amplification of the transistor lah. Okay. So the current amplification can be calculated as follows. So we're using this formula. So amplification factor, so will be IC over IB lah. Okay. So the amplification factor, we're using this symbol. Okay, normally we use as the beta. Okay. So it can be calculated by using the gradients of the graph here. Okay, this is the IC against IB. Okay, so the gradients referring to the amplification factor lah. Okay, so we can just take 2 points from the graph. Okay, so the first point will be 105, and then for the second point will be 210. Okay, so we're using we calculate the gradients now of the graph. So here will be Y1, Y2, right? Y1, Y2, S1 minus S2 lah. So here, the Y1 here can be here lah, or 210. Here will be 105. So 10 minus 5, so will be here. 200 minus 100 will be here. Okay, so you can equalize the unit here, milliampere and the microampere here. So milli, -3, micron, -6. Okay, so you get the amplification will be 50 lah. Okay, okay, then the next. So that from the discussion here through the circuit and also the graph lah, okay, we know that the small current change in the base, okay, will be resulting a big change of the collector current. So this shows that there is a current amplifier, okay, which is function of the transistor here. Okay, so we have really discussed for the connection with 2 batteries. So now we go to the another one, okay, will be the last one now. Okay, so the way of the connection of transistor by using 1 battery or 1 power supply here. Okay, so for this connection, which is in the 1 power supply, the transistor here will also adding as a current amplifier and also the automatic switch. Okay, so you can see here there is only 1 power supply, 1 battery here lah. Okay. So diagram show the potential or voltage divider circuit. Okay, so here it will be the potential divider circuit, which is the one power supply, and we have two resistors here. Okay, Rx and Ry here. So the function of two resistors Rx and Ry, which are connecting in series across the main battery, is a voltage divider. So be here, you can see connection with series. Okay. So resistance Rx and Ry divide the source voltage V. So the source voltage V here will be divided to Vx and Vb here. So the Vb here will be referring to the base voltage lah. Okay. So you can using this formula, the base voltage referring to here, Okay. So the resistance value here is Ry. Divide total resistance Rx plus Ry, multiply with the source here. So we get the voltage of the base lah. Okay, and then the next will be the Vx. So that means the voltage above the base circuit here. So be here. Okay, so we're using Rx resistance of this resistor divide total resistance Rx plus Ry. So multiply with V. Okay, so we get the Vx value here. Okay, so take note that large base current IB and collector current can damage the transistor. So here you can see, here is actually referring to NPN transistor lah. Okay, so the current will be flow into the transistor for base current and IC current. Okay, so the larger magnitude of the current IB and IC will damage the transistor. So that is why we need to reduce the current flow into the transistor by two resistors here, R1 and R2. So the purpose for these two resistors, R1 and R2 here, is used to reduce the current flow through the transistor, which may damage the transistor if the current magnitude is too high. Okay, so therefore the transistors at the base terminal R1 and transistor at the collector terminal R2 must be large to limit the size of current flowing into the transistor. So the R1 and R2 here, the main function is try to limit the magnitude of the current flow through the transistor. Okay, so we already know how the transistor work in one power supply here. So the first, we discuss the function of the transistor as the automatic switch. Okay, we're using the light sensor here. Okay, so the transistor as a light control switch. So we're using light sensor to control the current in the collector circuit here. Okay, so you can see here the circuit. Just now we have, for the potential divider, we need to have two resistor. So here we change one of the resistor become light sensor. Okay, so it will be LDR. In BM is PPC lah. Okay, so the PPC BM is bring down per cahaya. So for English will be light dependent resistor. Okay, the short form will be LDR and PPC for BM lah. So the character here will be has a very high resistance in dark. So actually for some of the book, okay, so they have the classification for the light sensor here. Okay, so but mainly in our syllabus we referring to the type of the negative. Okay, type of the negative. So that means that the high resistance will be give for the negative type of the sensor lah. Okay, in dark condition. Okay, so the light with the light, okay, presence of the light, so the resistance will be low lah. So let us look at the working principle here. The light dependent resistor LDR and a fixed resistor are connected in in series. So that means the same now. Two potential divider here will be connect in series to the source, okay, to our source power supply here. Okay, so the R referring to the 10 kilo ohm fixed resistor here. Okay, will be here. Okay, so the LDR and the resistor R here form a voltage divider in the circuit. Okay, so you can look at the figure here. So the circuit can be used to automatically switch on the bulb at night. Okay, so the bulb will be light up during the night. Okay, so but when we interchange the position of LDR with the R, so that means the LDR now at the above already. Okay, so the condition will be different. Okay, so the bulb will be light up during the daytime. Okay, so you can see if the position of LDR and R are interchanged, okay, so the bulb is switched on in the bright light and switch off in the dark. Okay, so this is the working principle for the light control switch here. Okay, so let us go to more detail. Okay, how the LDR resistance, okay, LDR resistance affect the value of VB, IB, and IC in the bright and dark condition. Okay, so here you can see we have two situations here. The first situation, the LDR is at the base circuit. Okay, and then the situation 2, the LDR is at the circuit above the base circuit. Okay, so be here. So you can see the first will be at the bottom. Second situation will be at the top. Okay, so we see in situation 1, how the resistance of LDR affect the value IB, VB, and the VC in the bright condition and dark condition. Okay, so as we mentioned just now, here will be the VB. Okay, here will be IB, base current. Here will be IC, collector current. Okay, and then another information we already mentioned just now. Okay, I mentioned just now. Okay, this is the resistance will be high in the dark for LDR. So in the bright condition, so the resistance will be low lah. Okay, so here will be very low. Okay, so from here, we know that the relationship between V and IR here, which is the Ohm's law, V equal to IR. So the V referring to the VB, R referring to the resistance of LDR. So here at the bright condition, the LDR resistance will be low. So from here, the value of VB will be low lah. Okay, so here the VB will be very low. So as we mentioned, we need to have the minimum VB, which is equal to 0.7 for the silicon type of transistor. Okay, so here that means that low. Okay, just now I mentioned already. So the VB must be greater than V. VJ here will be the junction voltage, which will be 0.7 for silicon type of semiconductor, 0.3 for the germanium type of semiconductor. Okay, so when the VB greater than VJ voltage junction, okay, so the carrier will be able to cross over the junction. So for here, we just discussed the NPN, so the carrier here will be electron. So when the electron flow through the junction, the IB will be flow through. Okay, and then the IC will be also flow through and light up the LED here. Okay, so for the bright condition, VB is low, so IB will be no flow lah. Okay, so too small to activate the transistor. Okay, so no IC flow. So IC referring to the collector current now. So LED is not light up. Okay, so we go to another condition, dark condition. So as I mentioned just now, for the dark condition, the resistance for LDR will be high. Okay, so when LDR resistance is high, so that means the VB will be high. Okay, so VB will be very high. That means that when the VB is greater than junction voltage, so the IB will be flow through the transistor here. So high enough to activate the transistor. Okay, so the IC is flowing. Okay, it's flowing and the LED is light up. Okay. So conclusion for situation 1, the LED light up in the dark and turn off in the bright condition. Okay. Okay, so for the situation 2, in the bright condition, again the same. When bright condition, LDR will have a low resistance. And then the VB, okay, so here you can see when the LDR is very low, so that means here the Vx here, so the voltage above the baseline will be here, will be higher. Okay, so will be low, sorry. So just now I mentioned will be low, so Vx will be low. Okay, so the relationship between Vx and VB will be here. So you can see the V referring to power supply, 6 volt here, and then Vx plus VB. So the VB is here actually. So it will be equal to 6 lah. Okay, so now because the value of Vx is low, so the VB will be high. Okay, so here will be high lah. So when VB is high, so that means it's greater than junction voltage, so the current will flow for IB. So high enough to activate the transistor. IC is flowing and LED is light up. So next will be the dark condition. So in dark condition, the LDR will be high resistance. Okay. So again, you can see we're using V equal to IR. So when LDR is high, Vx will be high. So relationship between VB to Vx, when the Vx is higher, VB will be lower. So when VB lower, so that means not able to cross over the junction. So IB will be not able to flow through. So the VB is very low. IB too small to activate the transistor. So no IC will be flow and the LDR light will be not light up. Okay, so the conclusion, the LED light up in the bright and turn off in the dark condition. Okay. Okay, then the second here is also transistor act as the automatic switch, but now we're using another sensor. We're using the heat or temperature sensor here, which is known as the thermistor. Okay, so be here. Okay, so the thermistor is heat or temperature sensitive resistor. Okay, so the character, so its resistance become very high when in cold condition now. Okay, so when the thermistor is heated, its resistance drop rapidly. So the transistor and the fixed resistor out. So here, thermistor and out here are connected in series. So this is the connection for the potential divider. So the potential divider here will be the thermistor and the fixed resistor out. The thermistor and out form a voltage divider in the circuit. So the circuit can be used to switch on the fire alarm system automatically. Okay, so system alarm will be here. The diode in the heat control circuit diode, okay, will be here, is to protect the transistor from being damaged by the large induced EMF in the relay coil when the collector current drop to 0. So this is the function for the diode. So it's to protect the transistor from damage when the IC value drop to 0. Okay, and then the function for the relay is used to connect the second circuit with higher power supply. So this is the function for the relay. Okay, so the working principle of fire alarm automatic switch. Okay, so we have also two conditions. First is will be at room temperature, which is referring to lower temperature condition. Okay, so again, you need to know the VB and Vx here. Okay, so we need to have higher value of VB to activate the alarm. Okay. Okay, so the thermistor has high resistance compared to out. Okay, because in the cold condition, so the resistance will be high at thermistor here. Okay. Core condition, resistance will be high, so the Vx will be high. So Vx high, the Vb will be low lah. So when Vb low, so there will be no current flow go through the transistor. Okay, so therefore the base voltage of the transistor is too low to switch on the transistor. Okay, the base current does not flow, so the IB is not flow and causes the corrector current does not flow. So that the relay circuit here, okay, is not activated. So the alarm also will be not ring, okay? And then for the second here, okay, so when the thermistor is heated, so for sure lah, when there is a fire, so the thermistor will be heated, okay? So now the resistance for the thermistor will become low lah, okay? As I mentioned just now, okay, when temperature increase, the resistance value for thermistor will be low. Okay, so Vx will be low lah. So when temperature rises, the resistance of the thermistor decreases significantly. The resistance of the thermistor is very small as compared to out. So here will be small. So that means the Vx will be small. And then the Vb will be higher already lah. Okay, if we follow the formula discussed just now, okay? Okay, so Vx will be low. So when the Vx low, that means that the Vb will be high lah. Okay, so IB will be flow through the transistor. So therefore, the base voltage is high enough to switch on the transistor. Okay, so when the transistor is switched on, the relay switch is activated and the alarm will be switched on. Okay, nah? Okay, so the IC will be flow through here, so the alarm will be activated lah, in the hot condition. Okay, so the last here will be the transistor as an amplifier. Okay, so when a person speaks through the microphone, so we hear microphone, the sound waves are converted into an alternating current. So the function for the microphone is converting sound wave to the alternating current here. Okay, so actually this is what you learn in the chapter electromagnetism here. Okay, you can see here will be the structure. So the structure of the microphone, okay, here. So here we have the cone. So the cone structure responds to the sound pressure. So when you speak, so the cone will be vibrate. Okay, when there is a motion, okay, between the magnet, which has the magnetic field, okay, so that means the current will be flow. Okay, so you can see when the sound wave causes the cone or the microphone to vibrate, the relative motion of the magnet and the coin here, okay, create an electrical signal by magnetic induction. So that means when you speak, the cone vibrate, causes the electric current, which is the induced current to produce. So the induced current here referring to the IB will be produced in the base circuit here. Okay, so that means the IB will be flow through the transistor. Okay, so a small current, so the small change in the base current IB will cause a big change in the corrector current IC. So now will be a big magnitude of the current IC will be flow through the corrector circuit here. Okay, so the loudspeaker first receive a large alternating current from the corrector circuit and converts it into the loud sound. So that means the loudspeaker function is convert alternating current to sound. Okay, so here will be also the same discussion, just reverse from the microphone. Okay, so the variation of the electric current, so the IC flow cause the variation of the magnetic field produced by electromagnet. So that means here the current will be flow through a magnet here, okay, magnetism field. So this causes the cone to move. So that means the current flow causes the cone to move. Okay, so the movement will creating the sound wave, which we can hear. Okay. Okay, so here we have another electronic components here in the circuit, which is a capacitor. So a capacitor here is to block a steady current, which is known as direct current from flowing into the transistor and microphone. Okay, so that means we're using transistor to amplify the sound from the microphone to the loudspeaker here. Okay, so there is a two function, which is the switch, automatic switch, and the amplifier current. Okay, for the transistor for two different connection, which is one battery or one power supply and two power supply. Okay, so we can take a break.
Okey, terima kasih kepada Cikgu Pei. Sekarang dengan lanjut dengan detail macam mana transistor boleh digunakan. Okey, sebelum kita nak berehat kita, kita berikan dahulu kod yang kedua, iaitu 73. 73. Okey, jangan pergi ke mana-mana, kembali selepas ini.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okey, baiklah, kembali semula. Okey, kami teruskan bersama dengan Mr. Pei. Dipersilakan Cikgu.
Okay, thank you, Puan Kok. Okay, so we have already finished our discussion for section 5.3. Okay, so now we go to the 4 questions related to our subtopic today. Okay, we have 2 objectives, one section A and one section C. Okay, so the first question is a question in 2006. Okay, so which of the following circuit can function? Okay, so here the first step, you have to identify the type of the transistor. So the first here, you can look at the arrow. So the arrow in represented that there is a PNP transistor. Okay, so for the PNP, so that means we have to know all the terminal here. The E must be P type, B must be N type, and the C must be the P type. Okay, then the second, we have to know that the connection for the transistor in forward bias, there is the forward bias for the BE circuit, which is the emitter diode, and the BC circuit here will be in the reverse bias here. Okay, so that means the positive. Okay, so here the BE here will be forward bias. So that means the E, which is the P type transistor here, must be connect to the positive lah. Okay, so here you can see connection to here positive correct, but connection to here wrong. So that means this circuit is not function lah. Okay, so here must be connect positive, here must be negative because of N type, and then here for the reverse bias here, the P type must be connect to negative terminal here. Okay, but here already wrong lah. Just like I mentioned already. Here correct, here is wrong. So A is wrong answer lah. Okay, so you can share your answer lah in chat room lah. Okay, students. Okay, so then the B, same lah. Okay, we need to know what terminal for E, B, and C here. So here must be positive. So you can see E connect to here. So here is not positive, here is negative. So B is also wrong. Okay, for C, you can see here again, we can check E emitter here lah, must be positive. So but here is negative. So that means it's also wrong lah. So we look at the D. Okay, here E positive, correct. So here you can see connect to positive. And here connect to the base circuit will be also positive, correct. So for the B must be negative because of N-type lah, huh? So negative, correct lah. Here is connect to negative. Then for B must be reverse bias. So here P-type, that means will be connect to negative. So correct lah. So the answer here will be D. Okay, then we go to the next question. Okay, question number 2. Okay, so diagram show the transistor circuit. Which of the following is the correct comparison between IE, IC, and IB? Okay, as per mentioned just now, the IB, the function is to amplify the IC. So that means the IB must be greater than IC. And then we have another relationship. IE is equal to IB plus IC. So that means the IE will be the, we have the greater values. Okay, so here is actually reverse. So that means the IE will be the greater, followed by IC. The smallest will be IB. Okay, so the answer will be C here. Okay, and then the last, the last second, okay, section A, question number 3. The circuit in the diagram is used as the heat operated switch. What is the component of X here? So the question already give you used to heat operated switch. So that means this is a heat sensor here. Okay, so the heat sensor must be thermistor lah. Okay, because we have another one is a light sensor, which is the LDR. Okay, so here thermistor is the sensor for the temperature. And then the second asks you to draw the component X. So this is a thermistor. The symbol will be like this now, 1 mark. Okay. And the third question, name the terminal A, B, and C. So it's quite straightforward. So A will be the base lah, right? Then C will be the emitter. And then this B will be corrector. So this, you need to memorize all the terminal for the transistor only lah. So it's quite straightforward. Okay, so the base will be A, B will be corrector, and then C will be emitter. Okay, so this is the application question. Okay, calculation. So in order to light up the bulb, the potential difference across X must be at least 4. So that means here is the voltage, is the junction voltage, okay, for the circuit here lah. Okay, so that means the minimum requirement to flow through the IB is 4 volt here. Okay, so what is the resistance of X when the bulb light up? So we need to find out the resistance X here. Okay, so what is the value of Rx here? So we have the formula. Just now we learned already. Okay, base voltage Vx. Here actually Vx. And the minimum requirement to activate the transistor will be 4 volt. Okay, so our Vx will be 4 lah. That means we need to have minimum 4. And then the V here given is 10. And then the R1 given 5K. So we need to find out what is the value of Rx here. Okay, so we substitute all the value in the equation. Okay, in the equation here. So we rearrange. Then we get our Rx will be 3.33 kilo ohm. Okay, so that means we need to have this value now, okay, so that the VB will be achieve the minimum value needed, which is 4 volt here, so that the transistor will be activated lah. Okay, then the second, what happens to the bulb if X has a resistance of 1K? Okay, so we have to calculate, is it 1K? Okay, the 1K is have the Vx higher than 4V or lower. Okay, if greater than 4V, that means the transistor will be activated and the bulb will be light up. Okay, so we check. So with Vx equal to 1K divided by total resistance times 10. So we get 1.67 volt. So which is lower than 4 volt lah. Okay, so the Vx lower than 4 volts, which is the minimum requirement to activate the transistor. So the bulb will be no light up lah. Okay. Okay, so we go to last 20 marks question. Okay, section C in 2017. So that means this type of question will be in the section B for our new format of SPM KSSM now. Okay, so the question is like this. Diagram 2.1 shows the symbol of transistor. So this is a symbol of transistor. So name the type of transistor. So when look at the type of transistor, referring to the arrow here. So you can see the arrow is up. So that means that the transistor here will be NPN. Okay, 1 mark. Okay, and then the next question is a 10-mark question. So diagram 2.1 shows for 4 circuit JKLM. So J, K, L, and M here. Dry cell containing detector. So there is a detector here, which is a LDR, light dependence resistor. So we here at J and L, just the position is different. And then we have another sensor here will be the thermistor. So the thermistor will be at the circuit K and circuit M here. So the position also different. Okay, and then we have the dry cell will be here. So here will be one power supply. Okay. And then we have the resistor R1. R1 will be here. It's actually the resistor for the potential divider. Okay, and then for the R, so the R is a resistor which to control or limiting the current flow through the circuit, transistor. Okay, so this is a transistor, and then we have the bulb here. So you are required to determine the most suitable circuit that can be used to light out the bulb automatically only when it is dark. Okay, so this is the requirement for the question. I already highlight in red here. Okay, so your study must be including this specification. Okay, so the first is the type of the detector. So that means you need to choose LDR or thermistor, and then the position of the detector is in the base circuit or above the base circuit here. Okay, and then the connection of the terminal of the dry cell. So here we have the positive at the top, negative at the bottom. Another one will be negative terminal at the top and the positive terminal at the bottom. Okay, so you need to choose which is the correct position. Okay, connection, sorry. So there will be transistor must be in the forward bias. Okay. And the fourth will be the position of the bulb. Okay, is in the VW location here. Or another one is at the SV here. You can look at the point here. So your answer can just mention the location with the alphabet here. Okay. Okay, so the first one, the type of the detector here, we have two options here, thermistor and the LDR. So as per mentioned, the question give here already, the sensors must be able to detect light, right? Because in the dark condition, there means no light. Okay. Okay, so the suitable here will be the LDR. So that means the thermistor will be out already. So that means the circuit K and circuit M will be not in the option already. Okay, we have to choose LDR. So all is out already. Then the second, the position of the detector. Okay, so look at the J and L. So one is at the bottom, TU, okay, at the TU. Another one is at the ST. Okay, so here, 2. So as per mentioned just now already, the LDR is high in dark. Okay, we have two conditions. So here when LDR in the dark, so in the circuit J, so that means the resistance will be high, the VB will be high. So when VB high, so that means the current will flow through the transistor, so be on, so the light will be on. So that means here J and L here we will choose at the position of TU here already lah, because the ST will be off lah. Why? Again, you can look at the discussion here. The LDR will be higher at the dark condition. So here the Vx will be high. So when Vx high, the Vb will be low lah. The Vb low, so that means no current will be flow. So the transistor will be off lah. Okay, and then the third one. Okay, so for sure we will not choose L already. So from here we already very clear that the option should be J already lah. Okay, and then for the third one will be the connection. So the connection here, as per mentioned, here we need to choose the forward bias for BE terminal, base emitter, and the base corrector terminal must be reverse bias. Okay, so here you can see we can check for E lah, E and the C here. Okay, so the E must be positive for forward bias, and then for the C, terminal C must be positive for reverse bias lah. Okay, so you can see here correct lah, here positive, here negative, so it's correct. Okay, then the last one is the position of the bulb. So for sure we know already here, so the position must be VW here lah, which able to allow the IC current to flow through lah. Okay, so we will choose J lah. Okay, so the advisable answer is in table form. So the first type of detector we choose LDR, reason to detect light. Position, as we mentioned, we need to choose TU lah. Okay, if let's say you want to give base circuit is actually accepted lah. Okay, TU voltage greater than R, right? Okay, so you can just give TU voltage greater. The third connection will be longer lah. Okay, you have to explain the terminal negative of the battery connect to emitter here. And then the positive terminal or battery will be connected to collector here. So reason, okay, because the transistor is in forward bias, or you can give the base and emitter terminal is forward bias, while the collector and base terminal, okay, is reverse bias lah. Then the last is the position for the bulb. As we mentioned, must be at the VW here lah, VW. Okay, so that correct current able to flow through and light out the bulb lah. Okay, so the option will be J. So you have to write down all lah. So your option will be detector is LDR. Okay, and the position is at TU. And the negative terminal of battery connected to emitter. Okay, and then, so that means you copy this, this, and this in the last, so that you can get your full mark lah. Okay, so last 5 mark for calculation. Diagram 2.3 shows a circuit which is used to amplify current. State whether there is a reading in microammeter and milliammeter. So we have to observe this and this lah. So the first, the switch 1 is on, but switch 2 is off. So that means there will be no IB. So no IB, so IC will be 0 lah. So that means both will be give 0 reading lah. Okay, so when switch 2 off, so IB is 0, IC will be 0. So no reading in both ammeter and milliammeter lah. Okay, then the S2, question 2 for the question 1 here. S1 is switch off. Okay, so now S1 is switch off, so that means this one is open. Then the switch 2 will be on, so we close. So that means the IB will be flow lah, but IC not able to flow. Okay, because this is an incomplete circuit lah. So switch 2 on, IB is flowing, but the switch 1 off, IC is 0. So that means the emitter, micro emitter, here we have the reading because it is used to measure the IB. Here we don't have any reading because IC not able to flow through with the open of the switch here. Okay, and then explain how the circuit function as a current amplifier when the rheostat is adjusted and the both switches are switched on. Okay, so both is switched on. So that means we have to flow through the IB So the IC will be amplified. So the first mark, a varying base current is produced when the rheostat is adjusted. So the point here you must mention IB is produced and the IC is amplified. Okay, so the small changes in the base current cause a big change in the collector current. So the current is amplified. So this will be the second mark. Okay, based on the diagram 2.3, the reading of microammeter is 10 microampere, and the reading for the milliammeter will be 1 milliampere. So be here. Okay, so this one measure IB, and here measure IC Question asks us to give the amplification factor here. Formula is also given. Okay, it's quite easy already. So IC divide IB. So that means the IC will be 1 milliampere here. The IB will be 10 microampere here. 3 marks. Second marks, you have to change their unit to be equalize the unit here. So I change to SI unit here, and then you get answer is 100. So 1 mark, second mark, third mark here. Okay, and then emitter current IE. So what's the value? So just now I highlight the formula already. So will be IE equal to IC plus IB here. Okay, so the IC 1 milliampere, IB 10 microampere. So we can equalize the unit, become 1 milliampere plus 0.01 milliampere. So we get our answer 1.01 milliampere here. Substitution 1 mark, answer 1 mark. Okay, so that's all for my sharing for subtitle 5.3. Okay, thank you.
Okey, terima kasih kepada Mr. P. Dan tahniah dan juga terima kasih diucapkan kepada semua yang setia mengikut kelas pada petang ini. Okey, sebelum kita nak tamatkan sesi siaran langsung hari ini, mohon tutupkan ruangan chat, klikkan butang subscribe dan aktifkan ikon loceng supaya kamu tidak terlepas sesi kelas Mr. P dan seterusnya. Okey, sila klik like dan juga share link kelas kita hari ini kepada rakan-rakan di media sosial anda. Jangan lupa ikuti kelas-kelas fizik seterusnya pada setiap hari Jumaat 9.30 malam untuk tingkatan 4 dan juga Ahad seperti hari ini pukul 2 petang untuk tingkatan 5. Layani portal www.academicyoutuber.com. Okey, untuk mendapatkan info terkini berkaitan kelas tuition PERCUMA AYU dan kongsikanlah kepada rakan-rakan dan juga guru di seluruh Malaysia. Okey, sekarang kami akan sharekan link sijil, link rekod kredit belajar serta username Mr. P pada chat room. Setelah diletakkan pada ruangan yang di chat tu, sila ambil perhatian, link tersebut akan tamat. Okey, dalam tempoh 30 minit sahaja. Okey, selepas live ni kami akan close lah. Setengah jam anda kena sempat masuk. Okey, pastikan anda login dengan email e-didik, email MOE, email My Guru dan juga email Jawi untuk bukakan link tersebut. Okey, sebelum cikgu nak tamatkan kelas pada petang ni, dipersilakan Cikgu P untuk memberi sepatah dua kata kepada murid-murid kita. Okey, dipersilakan Cikgu P.
Okay, so thank you kepada Cikgu Kok dan Cikgu Hasita bersama saya petang ini. So saya rasa hari ini punya kelas rush sedikit lah sebab panjang tak panjang, pendek tak pendek. So kalau buat dua siri macam pendek sangat, kalau buat satu siri panjang sangat. So hopefully pelajar boleh ikut lah. Sekiranya kamu rasa kerja, you boleh tengok balik lah. Okay, so saya sebenarnya sudah cuba buatkan nota yang semudah mungkin untuk para pelajar memahami. Sebenarnya transistor punya working principle sebenarnya agak susah kalau kita pergi detail lagi lah. Okay, so saya berikan apa yang saya boleh fahamkan para pelajar lah. Okay, so juga terima kasih kepada para pelajar yang join kelas saya hari ini lah, seperti Cingkit, Anissa dan lain-lain lah. So terima kasih lah. Okay, thank you.
Okay, terima kasih Mr. P. Okay, Cikgu Hasnita.
Okey, sedikit saja daripada saya. Assalamualaikum, selamat petang semua. Pertama sekali saya nak ucapkan tahniah. Terima kasih Mr. P. So siapa yang ikut kelas hari ini, saya rasa satu penjelasan yang sangat jelas, sangat detail dan nota pun mudah difahami. Jadi pelajar anda jangan lupa dapatkan nota yang dikongsikan oleh Mr. P. Mana nak dapat? Pergi tengok pada deskripsi video, ada link dekat sana. So you can download and print them out. Boleh muat turun dan cetak keluar. So kalau saya student, memang rugi kalau tak cetak keluar. So anda boleh baca kemudian and boleh guna sebagai bahan ulang kaji. Sekarang semua orang sudah rushing untuk percubaan kan, Cikgu Kok, Mr. P. So cikgu harap kami semua berharap kelas-kelas ini boleh membantu anda untuk menyediakan diri yang terbaiklah untuk anda punya percubaan. So macam Cikgu Kok bagi tahu tadi, jangan lupa bersama-sama dengan kami setiap Jumaat kita punya kelas tingkatan 4 9:30 malam dan untuk tingkatan 5 pukul 2 petang hari Ahad. So you should mark this 2 day on your calendar. Itu saja.
Okey, terima kasih Cikgu Hasita. So belajar dah dengar kan? Cepat-cepat pergi download nota untuk baca. Okey, percubaan SPM coming soon. So harap-harap belajar boleh menerima sesuatu ilmu yang baru ataupun yang ulang gaji supaya anda boleh mendapat keputusan yang baguslah pada exam yang coming soon. Okay, so akhirnya saya nak bagi kod yang terakhir iaitu nombor 58. 58. Okey, terima kasih kepada semua penyokong Akademi YouTuber. Sekian daripada kami. Salam dan jumpa lagi next week. Bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.